Okay, page 11 of Euler's complex numbers of MHL, chapter 16. Number 2, use de Moivre's theorem to simplify the following expressions. So remember that all we're doing is we are taking the modulus and taking it to the 10th exponent, and then we just put 10 as a multiplier of pi over 5. So this is like quite easy, although sometimes it's a little not intuitive. I think that's why I like Euler's form, because with Euler's form, it is intuitive. Okay, so I'm going to rewrite this. Square root of 2 to the 10th power is 2 to the 5th power, which is 32. And cis 10 pi over 5 is equal to cis 2 pi, which is equal to cis 0, which is basically just a positive number. So 32 is a positive number. That's it. Let's look at C. Square root of 2 to the 12th power, cis 12 pi over 8. And square root of 2 to the 12th power is equal to 2 to the 6th power, which happens to be 64. And cis 12 pi over 8 is equal to cis 3 halves pi, which we know is like negative I. So it's equal to negative 64i. Cube root of 8 cis pi over 2. So that's equal to the cube root of 8 times cis 1/3 pi over 2. So that is cube root of 8 is 2. The cis of pi over 3 over times 2 is pi over 6. So the cis of pi over 6, we drew a unit circle triangle, that would be that triangle there. So if the hypotenuse is 2, the sine is 1, and the cosine is square root of 3. So that would be equal to, you could either write 2 cis pi over 6, or you could write square root of 3 plus I. Number 3, use de Moivre's theorem to find the exact value of 1 plus I to the 15th power. Okay, so 1 plus I to the 15th power, I could write that as a, in cis form or in Euler's form. I would write square root of 2 because a triangle that has two sides that are 1, the hypotenuse is square root of 2 according to Pythagoras. So I could write square root of 2 e to the I pi over 4 because it's 45 degrees. And that is to the 15th power. So that is equal to square root of 2 to the 15th power e to the I 15 pi over 4. And square root of 2 to the 15th power is 2 to the 15 halves power. That's ugly. Times e to the I, 15 fourths pi. Let's reduce that. So let's subtract 2 pi's until it just becomes a small angle. So we could subtract 8 fourths pi once and we get 7 fourths pi, and then we're pretty much already there. We subtract 8 fourths pi one more time and we'll get negative pi over 4. Okay. So, which is an angle pointing kind of like that. So it's, okay, and the hypotenuse is 2 to the 15 halves power. So let's get a number for that. So 2 to the 7.5 would be 2 to the 15 halves power. And if I wanted to see what this looks like with that argument, then I could put this maybe as, I need to make sure I need to go in here and change it to A plus BI mode. And so I have this argument, and I'm going to multiply it times e to the I times negative pi, oops, not subtract, it's negative, not subtract, negative I, oops, negative pi divided by 4. So the answer is 128 minus 128 pi. I didn't think about that, but if you think about it, 2 to the 7.5 power is, 2 to the 6th times square root of 2. So when I divide square root of 2 from that, or 2 to the 7th times square root of 2, so yeah, that makes sense. Okay, because like, for example, if you have a side, if you have a 45, 45, 90 triangle and the hypotenuse is 128 times square root of 2, then each one of the legs is 128. That's why the real and the imaginary parts came out to be so nice there. Okay. C. So I have square root of 2 minus I square root of 2 quantity to the negative 19th. So the hypotenuse for this, square root of 2 minus square root of 2, so it would be square root of 2 minus square root of 2. And then the hypotenuse of this would be 2, of course. So it would be 2e to the negative, or e to the negative I pi over 4. And that is to the negative 19th power. So that is equal to 2 to the negative 19th e to the negative I 19 over 4. Now, it should be positive 19/4 because there was a negative here and a negative here, so they would become positive. Now, let's try to get 19/4 pi into something easier to understand. So if we subtract 2 pi from it a couple times, we'll get it to something between 180 degrees and negative 180 degrees. So we subtract 8/4, we'll get 11/4. We subtract 8/4 again, we'll get 3/4. So that's reasonable. So I 3/4 pi. And so that is equal to that. Okay, I made the 2 negative 19ths into 1 over 2 to the 19th. 2 to the 19th. That, I have no idea how much that is. 524,288. Okay, so it's 1 over 524,288. And we could write it in a plus bi form. So that would be, so 3/4 pi is an angle in that direction. So it would be negative square root of 2 over 2 plus I times square root of 2 over 2. So let's make this a little bit smaller, and then we'll move on to the last part. Put that there. Let's do that one. So square root of 3 minus I to the 1/2 power. So square root of 3 minus I is a 30, 60, 90 triangle. Square root of 3 in that direction minus I would be 1 in that direction. So that would mean that this would be a hypotenuse of 2, and the 30 degrees is there. So we could rewrite that as 2 times e to the I negative I pi over 6. and that is to the 1/2 power. So that would be 2 to the 1/2 power, e to the negative I pi over 12. And of course, that isn't pleasant at all. That would be square root of 2 times the cosine of pi over 12 minus, cosine of negative pi over 12, but that would be the same thing as cosine of pi over 12. And then I sine of pi over 12. I put a minus sign there because sine of negative pi over 12 would be negative sine of pi over 12. Show that cosine theta minus I sine theta equals the cosine of negative theta. Okay, so cosine theta minus I sine theta, that is the conjugate of cosine theta plus I sine theta. So the conjugate would be the angle that points down instead of points up. So maybe that's how we could say it. We could cis theta conjugate is equal to cosine theta minus I sine theta. And the conjugate is also equal to cis negative theta. Okay? Hence, simplify cosine theta minus I sine theta to the negative third. So that would be cis negative theta to the negative third. And remember, that's the same thing as e to the negative I theta to the negative third. And we can multiply the exponents, so it'll be e to the positive I 3 theta. And that's it, I think. Okay, number 7. Suppose that the modulus of z equals 2 and the argument of z is theta. Determine the modulus and argument of z cubed. Okay, so we got 2 e to the I theta, and that is equal to z. So z cubed would be 2 cubed e to the I theta cubed, which would be 8 times e to the I 3 theta. 1 over z. 1 over z is the same thing as z to the negative 1. So we could say z equals 2 e to the I theta. Z to the negative 1 is equal to 2 to the negative 1 e to the I theta negative 1, which is equal to 1/2 e to the negative I theta. So the modulus here is equal to 8, and the argument is equal to 3 theta. And here the modulus is equal to 1/2, and the argument is equal to negative